So large sample test. Already we discussed what is a large sample, what is a small sample. Basing on size of sample, if n greater than or equal to 30, we call that sample as large sample. If n less than 30, we call that sample as small sample. But here, for testing large samples, large sample means n greater than or equal to 30, we use following tests. The tests are test for single mean, test for difference of means, test for single proportion, test for difference of proportion. Difference of proportion. So these tests we are going to do in large sample. So 4 tests we are having. So whenever if you get a testing problem on large sample test, first sample size should be greater than or equal to 30. Next we need to decide which test we have to apply. So we will apply single mean test with one sample, only one sample needed. One sample you should have with mean and SD. In the question if you read, you have to get mean, SD, and also one sample you should have. If you have 2 samples and 2 means, SDs, if you have, we apply difference of means. You should have 2 sample sizes to apply test for difference of means. Test for single proportion, one sample with no mean and SD. There is no discussion about mean and SD in proportion test. Simply we have one sample with one value. With less data we can test single proportion. Here the same thing, 2 samples with no mean and SD. So these are the techniques to decide, few simple techniques to decide whether given test is single mean test or difference of means test or single proportion or difference of proportion. So coming to the first test, test for single mean. How to do large sample single mean test? What are the test steps involved in single mean? As I said, to test the single mean in large sample, we need one sample, size of sample, and mean SDs. Mean of population and mean of sample, both you need. We need 2 means, the 2 different means, sample means and one SD. So that type of data is useful to test single mean. To test the single mean, step 1, write H0. H0 is standard here, mu equal to mu naught. Mu naught is some value. Test on mean 30, then mu equal to 30. Test on mean 54, then mu equal to 54. Like that, you need to find the population mean. Here mu is population mean. population mean mu. H1, write alternative hypothesis. If you write here mu not equal to mu naught, that is two-tail test. Two-tail. If you write here mu less than mu naught or mu greater than mu naught, that test we will call it one-tail test. One-tail test. Now write alpha. Alpha may be generally 5% or 1% or 2% or 10%. Whenever alpha is not given, level of significance is not given in the question, we go for default. This is default 5%. We will take 5% as alpha. Now, next step, test statistic. Write the formula for getting calculated value, that is Z calculated value. We can find here using this formula, x bar minus mu by sigma by root n, where x bar is sample mean, mu is population mean or mean of population, sigma is SD of population, n is size of sample. So this data required to find Z calculated. Next, table value. Find table value. So here for large sample test we use some small table. If you can remember this one, no need of table, just 5 values. Alpha, if it is one tile, how to take? If it is two tile, how to take the value? Generally we will have 5%, 1%, 2%, 10%. These values we will have. These 5 values you need to by heart. 5% value is 1.96. So one tile, two tile I need to say. One tile test and two tile test. That will be decided in H1. After finding whether you are doing one tile or two tile, basing on that we are going to decide the value of H alpha, Z table value. Z table value we will calculate basing on level of significance. What is the percentage we are adding? If alpha percentage is given clearly, then we will decide the Z table value basing on that is one tile test or two tile test. So if it is one tile test, make it 2 alpha. If it is two tile, take alpha, direct value. So in one tile you are going to write 2 alpha value, in two tile you are going to write alpha value only. That means these are direct values. So for 5% you will have 1.96, for 1% 2.58, for 2% 2.33, for 10% 1.645. These values you need to remember. So here in one tile 5% you need to write 10% value, 1.645. For 1% you need to write 2% value, 2.33. These two no need, we won't get. So these table values you need to remember. If it is 5% two tile, 1.96. If it is 5% one tile, 1.645. Now the finally conclusion you need to write. The conclusion for this is, if Z calculated less than or equal to Z table, here you will get Z table value from this table, then accept H0, otherwise reject H0. So this plays key role to decide whether we need to accept H0 or reject H0. So this is testing procedure for testing single mean test. A sample of 64 students with mean weight of 70 kgs regarded as a sample from population mean of 56 kgs with SD 25. So now here we need to test single mean. How we can decide? We are having means and one sample of size 64. A sample of 64 students. Here 64 is greater than or equal to 30. When the size of sample is greater than or equal to 30, that sample is large sample. That test is large sample test. Again in large sample test, we have 4 tests. We need to decide which is suitable test. For that, after reading the question, find out how many samples you are having. Only one sample of size 64. That is greater than or equal to 30. Now we have mean, sample mean, one sample mean and population mean and SD. So one sample mean. One sample mean, single mean test. So we are going to do single mean test for this. In single mean test, the step 1 is writing H0. Writing H0. H0 is whether we have to decide that sample is came from the population with mean 56 kgs. So here we assume that sample is came from population with mean 56 kgs. That means mu equal to 56. H1. Here there are 3 chances: mu not equal to, mu less than, mu greater than. You need to oppose whatever you written in H0 in H1. For that, in the question if you mention particularly it is less than, greater than or not equal to, we can take that. Whenever you won't mention about H1 in the question, then by default you go for 2 tile test. You will take not equal to. If you write here not equal to, that is 2 tile test. If you write there less than or greater than, that is 1 tile. This plays key role while calculating table value, whether we are doing 1 tile or 2 tile. Next, we need to write a level of significance. There is no discussion about level of significance in the question. How much percentage of rejection is there for that claim? In that cases, default 5% we will take. This is default value. Whenever alpha is not given. Now coming to the test statistic. Test statistic, the formula to calculate calculated value. Before writing formula, write what is given data. So given n, size of sample is given, that is 64, which is greater than or equal to 30. So we decide that is large sample, and sample mean is given, X bar is given 70 kgs, and also population mean is there 56, population mean 56, and population SD sigma how much? 25. This is population mean, this is sample mean, this is SD. The difference between X bar and mu. This is sample mean, this is population mean, this is SD. Now we need to calculate Z calculated value, which has formula X bar minus mu by sigma by root n. What is X bar? 70 minus 56 by 25 by root 64. If you calculate this value, we call that one as calculated value. Use calc to get the calculated value. Here the calculated value is 4.48. Now what is table value? Table value Z table. Z table for 2 tile 5% 1.96. If it is 1 tile, we take double 2 alpha. Z table 1.96, Z calculated 4.48. Now compare. Z calculated is greater than Z table. So what we need to do? If Z calculated greater than Z table, simply reject H0. So finally we need to decide whether we have to accept H0 or reject H0. That is testing. So in a random sample of 60 workers, the sample size is greater than 30, large sample test, and to get work is an average. For 60 workers, mean is given, that is sample mean is given 33.8 minutes, and with SD of 1 SD is given. Can we reject the null hypothesis? Null hypothesis is given very clearly. H0 is given in the question. In the favor of alternative hypothesis, H1 also given, alpha given. So clearly, if you observe, one sample is there, one sample mean is there. With SD we are having sample size is greater than 30. So this is test for single mean in large sample. We call that one as Z test also. So now first write H0, which is given very clearly, mu equal to 32.6. Next H1, mu greater than 32.6, which is one tile test. One tile, mu greater than 32.6 means. Alpha also given 0.011%. 0.011% indirectly. Test statistic, that is formula. To get calculated value, first write given data. Given n is 60 greater than 30. Sample mean X bar is 33.8. Sigma 6.1. Mu 32.6. Now write Z calculated formula. Z calculated formula X bar minus mu by sigma by root n. What is X bar? 33.8 minus 32.6 by 6.1 by root 60. So you will get now Z calculated value. Use your calculator to get Z calculated. 1.523 you will get. Now write Z table value. Z table 1 tile 1%. In 1 tile, even though it is 1%, you will double alpha. 2% value you will write. The 2% value is 2.33 because the test is 1 tile value, 1 tile Z. If it is 2 tile, 2.58 we may take. Now here compare these two. If you compare these two, Z calculated less than Z table. When Z calculated value is less than Z table, what we will do? We will accept H0. So this is acceptable. Mu equal to 32.6 minutes. Answer is mu equal to 32.6 minutes. Accept H0. A sample of 400 items, sample size greater than 30, large sample, is taken from a population. SD is given. The mean of sample is given 40. Test whether the sample came from population with mean 38. With 38, also calculate 95% confidence interval for the population. We need to do the testing and also we have to find confidence interval also for the population. Now, if you observe in the problem, you have only one sample and one sample mean, another population mean and ST. One sample mean, one sample, if the sample size is greater than 30, we test here single mean. Test for single mean. Single mean testing we are going to do. So for that, we need to write first H0. H0 is population mean. Population mean is 38. H1, if you have any information regarding H1, note down. Otherwise, take H1 as not equal to. So which is 2 tile. Alpha 95% means level of significance 5%. 5% is alpha. Test statistic, that is formula. That is formula to calculate calculated value. First write given data N300 X bar sample mean of sample 40 and SD is 10 and mu is 38. Now write the formula. Z equal to X bar minus mu by sigma by root n. What is X bar? 40 minus mu value 38 by sigma 10 by root 300. If you calculate this value, you will get Z calculated. Z calculated is 4. Calculate that value using your calculator. Now Z table value, because this is 2 tile, we can take direct 5% value. 5% 1.96 2 tile. 5% standard 1.96. Now compare. Z calculated is greater than Z table. So what we will do? We will reject H0. That means accept H1. So H1 is answer. H1 is answered. What is H1? Mu not equal to 38. Along with this, we need to find confidence interval also. Confidence interval. The formula to find confidence interval for true mean in large sample test, x bar plus or minus z alpha by 2 into sigma by root n. That means x bar plus z alpha by 2, that is minus x bar minus z alpha by 2 into sigma by root n, x bar plus z alpha by 2 into sigma by root n. We know x bar 40, z alpha by 2 1.96, sigma 10 by root 300. 40 plus 1.96, 10 by root 300. Use your calculator to get that confidence interval. The confidence interval is, using calci, 39.02, 40.98. So this is confidence interval. So like this one can easily calculate confidence interval of large sample mean. Any doubts you may express anywhere.